sine and cosine functions today. Um, so before we get started, before we start defining these terms, let's talk about where this comes from. Here's a cool animation here. Let's start with sine. So, I think we're pretty familiar with what the graphs kind of look like, and but I think it would be important for us to understand like why and how this relates to the unit circle, which we've been spending a lot of time doing. So notice here, I'll try to pause it. Notice here, as we start at 0, our graph starts at 0, right? We're working with sine values right now. And then as we move up to pi over 2, notice here that we're at 1. And then as we come to pi, pause-ish, we're back at 0, and we work our way around at 3 pi over 2. Wow, my timing's terrible. At 3 pi over 2, we're at -1, and then as we finish here, we end up back at 0. And the same thing continues on and on because think of how many revolutions we can make, an infinite amount in both directions. The same thing is true for our cosine graph. Let's see if I can, there we go, at 0. So at 0, think about, our graph, we know, or hopefully we know that it starts at 1, which is true also on the unit circle. And as we go to, 90 degrees or pi over 2, now our cosine value is at 0, and so on. And everything between there, think about, our x values going around the unit circle. It's everything that's between -1 and 1. And then we put them together, and that's kind of cool too. Same curves, right? They have that same shape, but it's shifted over pi halves. Why is that? Well, because sine and cosine are co-functions of each other. So that's just kind of a cool thing to keep in mind. All right, so let's start looking at some of these vocabulary terms. The first one is amplitude. The amplitude represents half the distance between the max and the minimum values of the function. Okay, so for example, in these graphs here, we're going, let's just have one, between +1 and -1, right? So our amplitude, although the distance here is 2, our amplitude would just be 1, half that distance. Also, I need to get my marker here. This distance must be positive. Just something to keep in mind here. That same thing goes for period. That's our second vocabulary term today. Period is the distance of one complete cycle. Okay, so in this one that we had here, the complete cycle was 0 to 2 pi. And once we got past 2 pi, or maybe before we got to 0, that cycle would continue on. So that would be a period. Okay. Let's see, was there anything else on this page? Nope. Okay, so it says here, given the generic functions y equals 8 times the sine of bx and y equals 8 times the cosine of bx, it says here are the period and amplitude of some specific functions. So I think it would be really important for us to know this, because this is our parent functions, right? And then, of course, we can always, apply some transformations to them. So y equals sine of x and y equals cosine of x. The period, like I just explained in that simulation, was 2 pi, and the amplitude was 1. Remember, the distance from -1 to 1 was 2. Cut that in half, we get an amplitude of 1. And then you guys can notice here how this is affected. Okay, so that being said, for these other examples, like here we have y equals 2 times the sine of 3x. Notice this time that our period is 2 pi over 3, and our amplitude is 2. Even for y equals 2 times the cosine of 3x, notice that they're the same for both. And then you guys can kind of take a look here. Notice here, even though it's multiplied by -5, our amplitude is still +5. So now comparing these three examples to, like I said, this parent, I have a question for you. Or do I? Where did that slide go? There it is. Okay, here's my question. Is based on these examples and your previous knowledge, explain how to find the amplitude of any sine or cosine equation in this form. Likewise, I'd like you to explain how to find the period using this form. So go ahead, write down an answer, and then we'll see if you're right. All right, so here are my two answers here. Maybe you have something similar. So the amplitude is the absolute value of A, and then the period is the absolute value of 2 pi over B. Awesome. Okay, so basic functions, let's fill these out. So our amplitude here is 1, right? Because A in both of these is 1. Our period is going to be 2 pi over 1, which is just 2 pi. What about our domain and range? So, I think that we're very familiar with domain and range when we look at a graph, right? So what would our domain be here if this continues on and on? Well, all real numbers. You could also think of that in terms of your unit circle. Let's go back here. I could keep doing multiple revolutions around. Our range, what about our range, our y values? Well, it only goes from -1 to 1, including both of those values. All right, so again, here's our generic function, a times the sine of bx minus c. Now, we should be familiar with what this minus c does to it. It'll have some kind of horizontal shift. So for our amplitude, we already answered. Amplitude is the absolute value of a. Our period is going to be the absolute value of 2 pi over b. Absolute value, because both of these distances need to be positive. So here's something that's a little bit different. The horizontal phase or the horizontal shift, which you'll see me abbreviate with HS from now on, and vertical shift abbreviate with BS, not Victoria's Secret. But this horizontal shift, you want to set BX minus C equal to 0 and solve for X. And this will give you your starting X value. So again, your starting X value is where your period begins. Okay? And then your vertical shift, how is it moving up or down? Well, that would be, whatever constant we are adding or subtracting. So that would be just B. Okay, so some graphing strategies. It's always good to have graphing strategies. This can a lot of times be what's really difficult about trigonometry but honestly, once you get the hang of it, I think you guys will enjoy it. One thing I want us to keep in mind, this isn't part of our strategies, but just remember that one period for sine and cosine is going to be 5 points. Okay, that's what I'm going to be expecting of you guys to be able to graph. So for example, this is like my sine curve. I want to see this point, 1, 2, 3, 4, 5. I would want to see these 5 points and then the shape of your curve for the sine graph. And just keep in mind that since one period is 5 points, 2 periods would actually just be 9 points because this point will be used again. Likewise, for the cosine graph, this is what I'd want to see. I want to see these 5 points for one period. And if I ask you for 2 periods, then just know I'm looking for 9 points. Okay, so strategies. First thing that I would recommend doing is find the vertical shift. I should have abbreviated that. What was it? Find the vertical shift, because that will be your new horizontal axis. What do I mean by that? Well, here, this horizontal axis is at 0 because the graph wasn't shifted up or down. The second thing that I would recommend doing is find your amplitude. We already talked about how to find that. It's the A value, absolute value of it. Okay. Third, I would find your period. Okay, figure out how long is the period, which we know that's 2 pi over b. I don't know why this does that all the time. Fourth is you want to figure out what are your intervals going to be. And when I'm saying intervals, I'm saying about the intervals between these 5 points that you're graphing, or 9 if it's 2 periods. To do this is something I would expect you to know. You're going to take your period and divide it by 4. Just think about that. 1, 2, 3, 4. Okay, that makes sense. And if it doesn't, think about it harder. Okay, fifth, determine your starting x value. That's related to our horizontal shift. Already talked about how to find that. And then the last thing would be to plot your points. And obviously connect with a curve, because that's important. All right, so let's take a look at an example. We'll follow these strategies here. It says graph 2 periods of y equals 3 times sine of 2x. And when we do this, I think it's really helpful to start by just identifying, the pieces of information we need. So vertical shift, none. We don't have one. There's no addition of or subtraction of a number. Our amplitude here is 3. It's our A value. The period, remember that's 2 pi over b, which is 2 pi over 2. So our period's just pi. So keep in mind that 2 periods will go to 2 pi. Let's figure out our horizontal shift. Remember, to do that, we set that bx minus c equal to 0, so we get x equals 0. So that's where our graph will start. And one last important thing for us to figure out is our intervals. But remember, that's your period divided by 4. So it's going to go by pi fourths. Okay. So remember, there wasn't a vertical shift. So we know that that middle ground, I guess you could call it, is 0. We know that our amplitude goes to 3 and negative 3 then. Okay. Next thing is that we know that our intervals are pi over 4. So I have 1, 2, 3, 4. I know it's going to be 9 because I'm graphing 2 periods. So 1, 2, 3, 4, 5, 6, 7, really 8 because the first point starts at 0. I'm going to go to pi fourths, 2 pi over 4, 3 pi over 4, and then 4 pi over 4. That's 1 period. 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4. Last but not least, we're going to plot our points. Since this is a sine curve, we start at 0. 1, 2, 3, 4, 5. I want 2 periods. 6, 7, 8, 9. Last but not least, connect. That is nice. And that's my graph. Wasn't too bad, right? Awesome. So I'd like you guys to watch part 2. It's going to go through really the answers to the next couple of graphs in your notes. And that'll be all for graphing sine and cosine. So go tune into part 2.